So this one, drawing Hess cycle. So we're going to start with this question, which is that, basically one path is equal to the other path. The enthalpy changes would be the same. Like if you want to go from T to S, here's your one path and there's your other path. So both paths and the enthalpy changes and the energy changes are the same. This, as long as the starting point and the end point are the same. Okay, is that clear?
Yes, sir.
So in this question, they're saying that what's going to happen? What is the enthalpy change U to R? So you start at U and you're going to R. So U to R. There are two parts. One of them goes in this direction. You can't take the other one because you don't know what the enthalpy change over here is. And what happens is, okay, if you go in the opposite direction to the arrow, the sign of the enthalpy changes. So U to R would be, this would become minus 92, right? And this other one would become plus 134, right?
Yes.
So what do we get for this?
42.
So which is, so this is fine. The enthalpy change for the transformation T to S. So where is T and where is S? T to S, that's how you're going to reach T to S. So this is minus 75, right?
Yes.
And this one is going to be minus 92. So it's going to come out to be exothermic, right?
Yes, sir.
It's going to have a negative sign. So that's so that is wrong. And the third one is R to T. So how do you go from R all the way to T? So R to T is minus 134. Then it's plus 92, right?
Yes.
And this arrow is in the opposite direction, so that's going to be plus 75. So this, I think, comes out to be plus 33, not minus 33. So this one.
Yeah, it's plus 33.
So that is what Hess law is. So the other type, now this one was easy because they had drawn the Hess cycle. Now there are two ways of solving this. This is the difficult way. And the other way is through formulas, but formulas don't work always. We're going to come to formulas. We talk about those questions first. Like out of every 10 questions, one of them will be about drawing the Hess cycle. The formulas would only work if enthalpy of formations are given or enthalpy changes of combustion are given about an equation. Otherwise, the formula will not work. Like in this case, it's not going to work. Now, this one is cyclopropane. Cyclopropane is this thing. The first thing that they've given us, the enthalpy change of formation of cyclopropane. Cyclopropane is C3H6. This is a carbon atom, two hydrogens with this one. This one is a carbon atom with two hydrogens. This one is another carbon atom with two hydrogens, right? So that is cyclopropane. So what is enthalpy change of formation? That is elements. So it's going to take 3 carbons solid and 3 hydrogen gas molecules, and they're going to make you C3H6, right? Is that clear? And
yes.
And the value for that is 53.3. So this is 53.3. TK, is that clear?
Yes.
Now the other thing is they've given us the enthalpy change of atomization of graphite. Although atomization is no longer in your course, but atomization is that if you have an element, that element could be turned into atoms. So 3 carbon, gaseous atom. So what I've done is, I mean, the H2 is as it is. Nothing happens to it. So this is the atomization of carbon, that a carbon solid element in the form of graphite turns into carbon gaseous atom. So that's 717 kilojoules. 717. 1 second. So that's 717 kilojoules times 3. Is that clear? So I've connected this one over here, the atomization of graphite. Next, he's talking about the bond enthalpy of HH. So I've got an H2 gas molecule. What I'm going to do is I'm going to break the H2 bond. So the 3 carbons are already.
Sir,
Yes.
the 717 is just for the carbon, yeah?
Yes. It's the
Okay.
atomization of graphite. So I did not do anything to the H2 gas. Nothing happened to it.
Oh, yeah, okay.
Now, in the next step, what I'm doing is they've given us the HH bond enthalpy. So I'm going to break the HH bond. So I'm going to get 6 hydrogen gas atoms, right? So I've broken those bonds, and 436. So this would be 436 times 3 because that is for 1 bond. I'm breaking 3 molecules, right? Is that clear? Okay, so the only thing that changed over here is this part. Okay, is that clear? Mikal, clear? Munib?
Yes, sir, sorry. Yeah.
So then the last step is, once I have atoms, what I can do is I can make all these bonds, and I can make C3H6. So I can make all these bonds. How many bonds do I need to make? Once I've gotten atoms, I need to make 3 bonds between the carbon. So 3 carbon-carbon bonds, right? And bond formation is exothermic, so this should be negative, right? So this is 3 times the bond energy of the 3 carbon-carbon bonds, and I need to make 6 carbon and hydrogen bonds. So that is also going to be exothermic. Now they've given me the carbon and hydrogen bonds, that's 410. So I'm going to rub this off. This is 410. I know that this is. To make 1 bond of CH, it's 410 kilojoules of energy that is released. So I know this part. And in the question, they're asking for the CC bond. That's the only unknown. So what is the Hess law? That one path is equal to, so this is my path 1. And that over here is my path number 2. Okay, is that clear?
Yes.
Yes, sir.
So we're gonna, so I mean, this is Hess. Drawing the Hess cycle is difficult. I mean, the only thing you have to learn is, remember, most questions would be solved using a simple formula, not these ones. The formulas would only work for enthalpy changes of formation and enthalpy changes of combustion. I'm going to come to that later. I mean, I'm going to talk about. I'm just going to tell you, the formulas are conditional. Like if you have reactants and you have products and you want to find the enthalpy change of this, so if you either know the enthalpies of formation of the reactants and the products, then the formula would work. I mean, you can find out the enthalpy change of this reaction using a simple formula without actually drawing the Hess cycle. And the other one is, you've got reactants and products, and this is given, enthalpy of combustion of this is given, enthalpy of combustion of this is given, then formula would work. But not in these types of questions where atomization and bond enthalpies are given. Then obviously you would have to draw the whole thing. So we're going to try and work this out. Path 1 is equal to path 2. So it's 53.3. What is it equal to? What's the other path? That's 717 into 3. So this is then you have 436 into 3. Then you have minus 6 times 410. And you have minus 3 into Cc, which I'm going to write as x because that's what we are looking for. So it's minus 3 into, so can you try and do the math and tell me what x is? And you have to be careful with the math, especially when there are too many additions and subtractions. Please calculator निकालो ना ये करो कि क्या आ रहा है.
Sir, I got 315.
Yeah, so we do have 315, right? Yes, we do. So B is my answer.
Yeah.
So here's another one, and he's asking, Hess law can be used to calculate the average CH bond energy in methane. Which data values are needed in order to perform the calculation? So look at the first one, enthalpy. So remember CH bond energy. So and again, atomization is no longer in your course, but I'm still going to do that. So let's try the first one. Can you use this data? What is enthalpy of formation of CH4? That's carbon, solid, elements, 2H2 gas molecules, right? And it's going to give me CH4, which is a gas, obviously. So this value is known. I mean, they already gave us enthalpy of formation, and they gave us enthalpy change of atomization of carbon. So what is atomization? That this will turn into an atom. And they've also given me the atomization of hydrogen. So the element will turn into atoms. So 4 hydrogen gas atoms would be formed, right? I mean, so I've actually combined 2 steps. So this one is enthalpy of atomization of carbon, plus it's the enthalpy change of atomization of the hydrogen atom as well. And this is the enthalpy change of formation that they're talking about. So what do you have to do? You've got the elements. So all you have to do is you have to make the CH4 molecule. So how do you make the CH4 molecule? You're going to make 4 CH bonds. So that's 4 into the CH bond enthalpy. So in the whole cycle, if this is known, this is known, the only thing that's missing is this one. Then you can find this one, right? Is that clear?
Yes, sir.
So, I mean, A is fine. He's saying you were supposed to find the CH bond energy or bond enthalpy, so you can do that. But you can't do that for the other ones. I mean, you can definitely not do that for the other ones. Because you won't be able to make a cycle similar to this. Is that clear?
Yes, sir.
Yes, sir.
Like if I try to make a Hess cycle with this one, then the Hess cycle will not include a part where bond energies are being used. For example, if I have this enthalpy of combustion of carbon, enthalpy of combustion of hydrogen, and enthalpy of combustion of CH4. First thing is the Hess cycle will not be complete. Like if I start with the enthalpy of combustion of CH4, so that would be CH4 burning in oxygen, and it's going to produce CO2 and 2H2O, right? So that is the enthalpy change of combustion of CH4. What is the enthalpy change of combustion of carbon? That's carbon burning up to produce carbon dioxide. And also I can include hydrogen gas burning up to produce, when you burn hydrogen, that produces H2O. So that is the enthalpy of combustion of carbon and enthalpy of combustion of H2. So this part is enthalpy of combustion of carbon plus the enthalpy of combustion of H2. And this one was the enthalpy of combustion of CH4. But the Hess cycle is not complete. Why is it not complete? Because I don't know what this is. I mean, this is enthalpy of formation. Like elements turning into CH4. That is something getting formed from its elements. So that is enthalpy of formation. So that is not given in option B. So you can't make the Hess cycle in the first case. Is that clear? The Hess cycle is incomplete without this thing, and that is not given.
Yes, sir.
Yes, sir.
Plus, even if that's given, there is no mention of bond enthalpies in any place in the Hess cycle. You can only find those values which are given in the Hess cycle. Like if enthalpy of combustion of this was given, this was given, this was given, then you can find the enthalpy of formation of CH4. But there's no place where bond energies are used. So anyways, next one. Now you're given this data, and this is what you have to calculate. So you're going to try, and this is what they're looking for. Okay, what's the enthalpy change of this? So we're going to try and create the other route. The other route is that they've given us that calcium solid can turn into calcium gas. So I'm going to do just that. So calcium solid, I'm going to turn it into calcium gas, and everything else remains exactly the same. Minus 2 electrons, right? So this is 177. I mean, this path. The only thing that has happened is calcium solid has turned into calcium gas. Is that clear?
Yes, sir.
So similarly, they've told me that calcium 2 plus aqueous can be formed using these two. So I've got calcium 2 plus aqueous, and they've told me that it can be formed using calcium 2 plus gas plus aqueous. Is that clear? So it's this reaction, that's minus 1565.
Yes, sir.
So I've basically connected the two informations that were provided. I turned calcium solid to calcium gas. That's 177. They told me that calcium 2 plus aqueous can be formed using this. I did that. So that's minus 1565. So what do you think? I mean, the cycle is not complete. What do you think this path is? Like, what's happening here?
Like the electrons are getting removed.
Yes. So remember this. If something is present at both ends of the equation, that means that is not doing anything, right? So in this part, the aqueous part has no meaning at all. I mean, is that clear?
Yes, sir.
So when you look at this path, you can think, you can think of aqueous as being invisible. Like, it's not doing anything at this point. What is basically happening is that a calcium atom is losing 2 electrons and it's turning into calcium 2 plus ion. So that's the first plus, second ionization energy. And that is given in the data booklet. That's 590 and 1150. From now on, it will be given as part of the question, but this part is given in the data booklet. So your cycle is now complete. Your cycle is, you have to start from this point. And like if I can, so you have to go all the way from this point to that point, right? So that's your one path, the one direct path, the other one is the indirect path. And both of them are going to be equal. So your indirect path is 177 plus 590 plus 1150. And then there is minus 1565 as well. So what do you get?
352, sir.
So I got D as my answer. Next one is I have to find the enthalpy change of this reaction. I have to start from this point, and I have to reach the other point. So I'm going to make an alternate path. So what is given? They're saying that CO turns into CO2, and it gives off minus 283 kilojoules of energy. So CO over here, it turns into CO2. So we're going to do exactly that. And H2O gas remains as it is. So this path has a value of minus 283. Is that clear?
Yes, sir.
So CO turns into CO2. So that's fine. And what else? So this is, I've already connected this one. They're telling me that H2 changes into H2O liquid. So I've got H2 gas over here. So they're saying that it turns into H2O liquid. So let's do that. So CO2 remains as it is. H2 turns into H2O liquid. And the enthalpy change for that is minus 286. So this thing over here is minus 286. Right? Is that clear? So I've connected the.
Yes, sir.
I said now the only thing left is this middle path. What is this path? For the cycle to be complete. So it's what's happening in this path. I mean, CO2 was a gas.
H2 liquid is becoming gas.
CO2 was a gas. Remember that. CO gas turns into CO2 gas. This CO2 was a gas. So nothing is happening to CO2. Remember, if something is the same at both ends, then that means nothing is happening to it. So H2O liquid turns into H2O gas. So H2O liquid turning into H2O gas, that would be plus 44, right?
Yes, sir.
I mean, I have to go in the opposite direction, right? So that's going to be plus 44. Now, for the cycle to be complete, one of the routes, one of the paths has to be, its direction has to be changed. So it's going to be minus 286 and plus 44.
You get 41, sir.
And plus 283, right?
Yes.
So you're getting plus 41 or minus 41?
Plus 41. Yes.
So you're getting plus 41. So then this one. He's saying, what is the standard enthalpy change of formation of Iclc solid? So what is enthalpy change of formation of Iclc solid? I'm going to make the equation. The substance forming from its elements. What are the elements? It's iodine plus Cl2. And Cl2 is going to be gas. Iodine is going to be a solid, and it has to be balanced. Enthalpy change of formation is for 1 mole. So this should be half I2, and this should be 3/2 Cl2. Is that clear?
Sir, shouldn't it be 1, 3, and 2?
What's 1, 3, and 2?
Because the equation is given.
Which equation?
The formation of Iclc.
No, that's not formation. Is that formation? No, that's not formation.
What is that, sir?
What do you think? That's not formation. That it's 1 mole of a substance. Formation is when 1 mole of a substance is formed from its constituent elements, and the elements have to be in the standard state. What do you think should the state of iodine be? It should be a
solid or not.
So this one is not formation.
All right.
Because the element has to
What's
be.
the standard state of iodine?
It's a solid. It's a blue-black solid. I mean, that's the standard. That's the standard state of iodine. Chlorine definitely is a gas at room temperature. If there was bromine, then bromine was a liquid. Okay, so remember the elements have to be. So this is formation. This is what you're looking for. This is what you need to find. Now remember one thing, that solving fractions is kind of difficult. So I'm going to multiply this entire equation by 2. So that I get rid of this 1/2, right? And this would become 3. and this would become 2. And so you're basically so this is 2x now. Is that clear?
Yes, and then at the end you just divide by 2. Yeah.
You'll just find x, so you'll obviously divide by 2 automatically.
Yeah.
Right?
Okay.
So what is given is that they're turning I2 solid into I2 gas. That's plus 38. So that's what we're going to do. I2 solid, right? We're going to turn it into I2 gas. So that is plus 38. Is that clear? And then you have the
Yes,
first. Then you have the first one. I2 gas reacting with 3Cl2 gas to form 2 ICl3 solid. That is going to be minus 214. And one path is equal to the other path. So 2x is equal to plus 38 and minus 214, and x would come out to be
minus 88.
so it's coming out at minus 88. So the next one is also kind of I forget this one. This was also kind of a similar question. They're again asking for the enthalpy change of formation of ICl3, so I2 solid, 3Cl2 gas, and you're getting 2 ICl3 solid. And this is 2x. Again, I've doubled it, right? So the first part is, so I'm going to start with this one. I'm going to connect with this one. It's ICl3 solid. They're saying that ICl3 solid can be formed using this, right? So it could be formed using ICl solid plus Cl2 gas. I would have to double everything. And this would be minus 88 times 2, right? Is that clear?
Yes, sir.
So this is exactly the same. Let me just ICl3 solid, yes. And then you have this one, that I2 and Cl2 can react to form 2 ICl solid. That's this path. I2 and Cl2 can react to form 2 ICl3 solid, and that would be plus 14. And yes, that's going to be plus 14. Is that clear? And remember, this
Yes, sir.
path is the same as this path, because I2 reacts with only one Cl2. So I2 is reacting with 3 Cl2, but 2 Cl2 remain unreacted at the end. So that means I2 is basically reacting with just one Cl2 to form 2 ICl solid. So it's exactly the same. So 2 Cl2s over here, they remain unreacted in this path. Is that clear? So it's the same path.
Yes, sir.
Yes, sir.
So what do you get for this?
Minus 81, sir.
See, you're going to get C. Now that's about drawing Hess cycle. Now the other questions, the other version of the question is very easy. The other version of the question is with formulas. But the formulas are conditional. You can't apply the formulas to every question. So you have to look out for the right type of question. So the formulas, so it's if enthalpy, so the formula idea is simple. You don't need to draw the Hess cycle. You've got reactants, you've got your products, right? So, I mean, you can try drawing the Hess cycle, but there's no need for that. I mean, the question can be solved in both ways. So if enthalpy change of formation is given for the reactant and the product as well. So all you have to do is enthalpy of formation of products minus the enthalpy of formation of reactants, you'll find the enthalpy change of this reaction. Vice versa, if you have an equation and they've given you the enthalpy of combustion and the enthalpy of combustion of the product as well. So all you have to do is enthalpy of combustion of the products minus the enthalpy of combustion of the reactants, and you will be able to find that out.
So reactants minus products same the combustion.
So reactants minus products, okay? Clear?
Yes, sir.
So abhi wala this one, what is the standard enthalpy change of combustion of ethanol? So pehle to write down the equation. What is the enthalpy? Achha, remember, don't focus on what they're looking for. Focus on what the data is given. Are you given enthalpy of formations or are you given enthalpy of combustion? So the equation, the equation itself is irrelevant. What are the reactants? What are the products? It's completely irrelevant. Is it an equation for the enthalpy of combustion or is it an equation for the enthalpy of formation or whatever? Okay? So the equation itself is kind of irrelevant. So over here, don't get confused. They're looking for the enthalpy of combustion. We don't care about this thing. So what is more important is, I'm going to write down the equation. So what is the equation for enthalpy of combustion of ethanol? That's ethanol burning with oxygen. That's going to be 3 O2s. एक सेकंड इसको बंद कर लें. अच्छा, so it's going to react with CO2 and it will produce, I think, two CO2s and 3 H2s. So that's the reaction. This is going to be a liquid. This is a gas. This is a gas, and that's a liquid. So all you have to do is, so what is the data that's given? So are you given the enthalpy of formation of carbon dioxide? That is given. It's given over here. You're given the enthalpy of formation of water. That's given. You're given the enthalpy of formation of ethanol. And remember, elements, the enthalpy of formation of elements is always 0. That data will never be given, but that's going to be 0. So all you have to, so you're given the enthalpy of formation of the products, and you're given the enthalpy of formation of the reactant. So you're going to do product minus reactant. So it's going to be 3 H2Os, that's 3. So product minus reactants, right? So 3 H2Os, so that's 3 into minus 286. You have to be very careful about the signs. Use brackets. It's 2 CO2s. CO2s are 2 into minus 393, right? And minus the reactant, which is ethanol, that's minus 277 into 1. O2 is 0. That's your answer. Is that clear?
Yes, sir.
To kya bana it's
So that gives you minus 1367. B.
it's B.
Yes.
The next one, again, remember the equation is irrelevant. What is the data that's given? The enthalpy of formation of H2S is given. The enthalpy of elements is already known. The enthalpy of formation of H2 is also given, and so it's going to be product minus reactants, right? Because enthalpy changes off.
Yes, sir.
So it's going to be
Formation.
product minus reactants. So it's going to be, what is H2O? That's minus 286 times 2. And SO2, that's minus 297 times 2. And minus the reactant, which is H2S, that's minus 21 times 2. O2 is 0. इसका क्या है?
B as well, sir.
So you're getting, so this is very simple. Okay? All your, again, combustion of meat. The only problem I see is that people get confused when they see combustion written. ठीक है, remember the कि जिसकी निकालनी है ना enthalpy change, that is irrelevant, it could be anything. ठीक है, so methane combustion is this thing, so it would form CO2 and 2 H2Os, and I think O2 would be 2. This is going to be a gas, and this is a liquid. अच्छा, क्या क्या given है? Formations are given. The data is given for the formation of carbon dioxide. It's given for the formation of H2O, formation of methane, and O2 is automatically 0. So it's going to be, बस वही कर लो, product minus reactants. Is that clear? ठीक है, वो solve करने की जरूरत है. ये भी formations are given.
एक मिनट सर,
Yes.
ऊपर जाएंगे वापस से.
हाँ,
इसमें क्या डिफरेंस था?
कोई difference नहीं है. किससे related difference?
इसमें मतलब इसमें फॉर्मेशंस दिए हैं तो वो फॉर्मेशन वाला ही फॉर्मूला यूज करना है ना?
हाँ, product minus reactants होगा ना.
तो कंबस्शन का फॉर्मूला क्या था? रिएक्टेंट्स माइनस प्रोडक्ट.
हाँ, मैं बस ये कह रहा हूँ
Yes.
कि मैं बस ये कह रहा हूँ कंफ्यूजन कहाँ पे होती है कि people hear the term combustion तो वो combustion का फॉर्मूला यूज करना शुरू कर देते हैं. I'm just saying कि वो जो equation that's given, that is irrelevant. वो जो मर्जी है, ठीक है. What is important is, what do you know about the products? What do you know about the reactants? If you know the formation of the products and you know the formation of the reactants, the formula would
So
be
we go on the basis of the information they've given.
about the equation, about the products and about the reactants. The equation itself is irrelevant.
Okay, sir.
ठीक है.
Yeah, okay, sir.
Okay.
तो इसमें भी वही होगा. This one would be product minus reactants, right? Because formation of this is given, formation of this is given.
Yes, sir.
This one, I think, actually, this one is kind of a tricky question because what they'll do is uses what is the enthalpy change of combustion of propanone? That's C3860. The combustion equation would be like this. It's going to be 3 CO2s and 3 H2Os, right? Or jitne marzi oxygen, so that's 3226 plus 39, so that's 4 O2s, right? Plus 1 oxygen. Anyways, now they've given us the combustion of hydrogen, they've given us the combustion of carbon, and they've given us the formation of propanone. तो ये given है, इसकी formation given है, इसकी formation given नहीं है. That's not given in the data. How do you solve this?
They're like the opposite, right?
अगर
combustion of तो formation is the opposite.
Not the opposite, it's the same thing. Combustion of H2 is the same as formation of H2O.
So it's still negative 286.
It's going to be, so because combustion, what happens? H2 burns with oxygen to produce H2. So both of them are exactly the same. And also remember, combustion of carbon and formation of CO2 are the same thing.
So sir, we'll have to memorize these.
I mean, you don't have to memorize the value. You have to memorize that in certain instances, the combustion of something and the formation of something are kind of the same reaction, and they have the same enthalpy change.
All right. Okay.
ठीक है, खास तौर पे इसका याद रख लो कि इसका तो definitely याद रख लो. So when they give you the enthalpy of combustion of hydrogen, they're basically giving you the enthalpy of formation of H2O. When they give you the enthalpy of combustion of carbon, they're basically giving you the enthalpy of formation of CO2. ठीक है, और elements की enthalpy of formation जो है वो वैसी 0 है. ठीक है, that's
okay, sir.
तो इस चीज का ख्याल रखना, मतलब that's the और combustion में.
So sir, in the end, we just do products minus reactants, right?
हाँ, it's किधर गया? So it is product minus reactants, right?
All right.
I mean, that was the only tricky part here. Where do you get the enthalpy of formation of carbon dioxide? It's basically the same thing as this. अच्छा, फिर ये combustion वाला आ गया कि enthalpy of combustion of the reactants are given and enthalpy of combustion of the products are given. So it's going to be reactant minus products in this case. Is that clear?
Yes, sir.
So it's going to be reactant minus products. Now, इस पे भी ना ख्याल ये रखना है कि enthalpy of combustion of certain things is always zero. Like CO2, that is zero. Enthalpy of combustion, because you can't burn CO2. Because it's already, enthalpy of combustion of H2O is zero. Anything that has already combusted, uski enthalpy of combustion, that is going to come out to be zero. Is that also clear?
All right, sir. Yes.
So formation में याद रखना कि elements is zero, or combustion में याद रखना कि anything that's already combusted, its enthalpy of combustion is going to be zero, क्योंकि it won't combust anymore. ठीक है, so CO2 को you can't burn in oxygen and produce. What you'll get CO2 again. So nothing is happening. So in सारों में बस product minus reactants, again formation given, product minus reactants, ठीक है. ये वाले ज़्यादातर easy हैं, ठीक है. In इस case में combustion is given, तो reactant minus मतलब पहले तो equation figure out करोगे. Okay, what is the equation that they're looking for? Formation of propanone, so that's C3H6O. And it's going to be 3C plus 3H2 and plus oxygen. So, अच्छा, oxygen की combustion भी zero है. I mean, you can't burn oxygen in oxygen, so that is also zero. Okay, so it's going to be क्या given है? Hydrogen की combustion given है, carbon की combustion given है, O2 is already zero, this is given, so it's going to be a reactant minus products. Is that clear?
Yes, sir.
ठीक है.
Yes, sir.
तो बस combustion में ख्याल रखना है कि O2 की combustion वैसे ही zero है. Anything that cannot be burnt further, that enthalpy of combustion is zero, especially carbon dioxide, H2 and O2. And formation में anything that is an element, uski formation is zero, because you can't form an element from an element because it's already formed. So that would be zero. चलो ठीक है, ये पूरा complete हो गया है. Hess law के सारा वो complete. Drawing Hess cycle is difficult, but doing the formulas, that's very easy. ठीक है.
All right, sir.
चले.
Okay, sir.
Okay.
Okay, sir. Allah Hafiz. Oh,
Okay,
sir.
sir. Assalamu alaikum.
हाँ जी.
About tomorrow's class.
मैं
कितने
उसका
बजे?
हाँ मैं वो चेंज कर देता हूँ, ठीक है.
Okay, thank you, sir.
Office.
Okay, sir.
Allah
Assalamu alaikum.